Right. Good morning. So, in terms of what you have to do, let me just explain. Let me just re explain. So, the purpose of the live stream is just to help you guys out when it comes to, having someone explain it to you, because I know that it might be a bit difficult just learning it on your own from Seneca or BBC Bite Size. It might be a little bit challenging. So basically, this is just a way for you to be able to feel confident in the topic, whereas maybe with just learning on your own, you might feel a little bit like unsure. That's the main purpose. So when it comes to you having to do everything, no, you don't have to do this. This is completely optional. As I said, I'm going to be doing these videos anyway, just to help you guys out. In terms of what the obligations, what you have to do for the science department, that's all been put on Show My Homework from Mr. Durston anyway, where you're going to be assessed on unicellular organisms at some point after Easter break. And when you do that assessment, it's just if you want to approach it with a bit more confidence, then feel free. What you have to do is you have to do the Seneca, and you have to do the mini projects that Mr. Durston put up for this topic for unicellular organisms. So that is what you have to do. But these are just additional resources for you in order to help you with a bit of extra practice. So instead of just, doing like random bits here and there, you can really focus a bit more. And because I'll be going over the answers to this practice, hopefully you'll develop a bit more confidence. Okay, so what you have to do is what Mr. Durston set on Show My Homework. That's the bare minimum. If you want to feel like you really mastered the topic, obviously I have the additional practice here for you. And I'll be going over the answers on this stream. Okay? So let's get started. If you want to do notes, I do have on the website the Year 8 section and a booklet, because I know a lot of you guys enjoy having notes organized so you know exactly what you need to know. Okay? So I'll be explaining as I fill in my booklet, and then if you want, you can do it yourself. Hang on a second, because I want to actually upload a Word document instead, so you can type things in instead of needing to print it out or anything like that. Let me just quickly upload the Word document. It'll take me 2 seconds. Okay, yeah, the Word document has now been uploaded. So if you click on it, you get it to Google Drive, but make sure you click download instead so it opens up as a Word file. That way you can type things in. And also when you upload things on Google Documents, sometimes, like if you'll notice, it's just a black bar up top. Sometimes the formatting goes a little bit wonky. So make sure that you click download instead. There we go. All the formatting is correct. Okay. So, In terms of what you have to know for this unicellular organisms topic, the first thing that I want you guys to understand is what being unicellular means. Okay? What being unicellular means. So, the opposite of being unicellular is multicellular. If you think about the prefix, which is basically the start of this word, uni, that means one. So like, for example, unicycle, and multi means many. So if something is unicellular, you can break down that word actually and deduce, so work out that unicellular means organisms that are only made up of one cell. This is on the year 8 page. So I'll link it now. Just give me 1 second. I'll put it in the chat. And remember, if you click on a Word document, that will allow you to type things in, but make sure you download it first. So then it actually opens up as a file instead of being the online Google Drive, what it shows. And multicellular, what I would say is organisms made up of many cells. So examples would be like us. We are multicellular organisms. Okay, so in terms of what this means for the way nutrients get in and out, if you think about the fact that cells are very, very small, and each of our individual cells needs nutrients in order to survive. They need sugars to carry on with respiration, which is making energy for the cell. They need they need water. They need all of these resources, and the way that things get into cells, individual cells, is through this process known as diffusion. We would have talked about diffusion before many times in lessons, but hopefully we can remember what diffusion means. Can anyone in the chat tell me what does diffusion mean, or as best description as they can possibly give, what is diffusion in terms of the definition? We don't have to, give it in terms of scientific keywords. Just straightforward, what do you know about diffusion already? I will draw a sticker for anyone who can tell me. This will be the sticker. And then I'll write your name on here. No, that's digestion. Digestion is breaking down. What is diffusion? I'll give you an example of diffusion to hopefully get you guys thinking. Is if you spray perfume in one corner of the room, it moves then across the room to someone on the other side of the room being able to smell it. Okay, so diffusion, Max gets the sticker. But I'm going to cut that definition down a little bit just to make it a bit more cleaner. Max, that is a perfect definition for GCSE level. But just for now, I'm going to say that it's just the movement of the particles from where there are a lot to where there are many. So movement of the particles. I'm going to say actually where they spread out. So for example, when you have a bunch of particles all clogged up in one space, they naturally want to spread themselves out a bit to, be able to cover the whole area of the room. So our cells, they all basically absorb nutrients by diffusion. If you have a look at the diagrams that I have here, my yellow bit here is a cell, so this is a cell. And all the little gray dots on the outside are my nutrients that the cell wants on the inside. Because there's a lot of those nutrients on the outside of the cell, they naturally just want to spread themselves out and be able to go where there aren't many, to spread themselves out a bit more evenly. So they're going to naturally want to go inside the cell, and then over time you'll notice that all of the little gray dots, they're all even now, evenly spread out in this whole space inside the cell and outside the cell. So let's have a think about it now. Another sticker drawn. Another sticker is just drawn there. Why do we think in terms of our cells needing nutrients? If you think about this picture now and what diffusion is how we get the nutrients inside the cells. Why do you think that the cells have to be very small? If a cell was super, super big, what do you think would happen to diffusion? Adam, I'm mainly talking about how if you had a cell, let's pretend that we had a cell that was like a lot bigger. And the middle of the cell wants those nutrients as fast as possible. Do you think it would go faster or slower if the cell was really big? So there's a, yes, very good. Who is no again? So I can write the name on the sticker. Lucy. Oh, there we go. So I drew it by here where, let's say I have two cells. One is very small, one is very big. For both of them, the fusion happens, but it's going to go a lot slower for the bigger one for these outside nutrients to be able to reach the center than it is for the smaller one. So for example, where, this applies to anything, like if you were cooking and you were marinating chicken, for instance, it's a lot faster for the marinade to get in if you cut the chicken into small pieces rather than having it be sort of just a large chunk of chicken. It would take a lot slower then for the marinade to get through. This is the same principle. So in terms of why do cells have to be very small? In order to get nutrients, diffusion time quicker. And if you also think about the fact that maybe at the center of the cell there could be any sort of toxins, by the time those toxins diffuse out of the cell, it might be that the cell might already be dead. So things getting into and out of the cell, if you have a very large cell, it's going to be a lot more difficult. It's going to be a lot slower than if the cell was small. Right, so there are a few organisms that basically only exist as one small cell. And we call them microorganisms. If you think about the prefix micro, like such as microscope and things like that, we're talking about things that are very, very small where we can't actually see. And this would be very relevant to today because we have, a lot of concerns with microorganisms now, although coronavirus is technically not a living thing. So what are microorganisms? Microorganisms are unicellular, so one-cell organisms. That are very small. And we have some examples. We have some examples such as bacteria, fungus, and protists. Protoctis are our main ones. So we're going to talk about fungus first, what fungus are. Okay, so has anyone here ever had athlete's foot or ringworm? It's very easy to get, so don't be shy. Oh, prokaryotes are bacteria. Well, those would be fungal infections. So fungus, we can have multicellular fungus, such as mushrooms, but we can also have unicellular fungus, which are things like yeast. So yeast is a really good example of a unicellular fungus, okay? And first we have to know about how yeast reproduce. So we start off with a single yeast cell, and basically what happens is that there grows a little sort of nub there that buds off repeatedly until you have multiple, and then these small ones then go off and then continue to grow larger as yeast cells. Yes, very good. Yeast is used in making bread. So we call this process budding, is what we call it, where basically we start off with one yeast cell, and then there's a little tiny bud that comes off, and then we have multiple of them coming off, and then they bud off and then go on to grow to become larger yeast cells that go on then to form buds themselves. And in order for yeast or unicellular fungus to grow, we need several things. Can anyone think of potentially something that we need? I will draw a star by here. Can anyone think of something that yeast might need to grow? Water, yeah. So we need moisture. Very good. Warmth. And they don't actually need oxygen because they can reproduce anaerobically, meaning without oxygen. So oxygen isn't one of them. Sugar, very good. So they need some nutrients, sugar. They don't actually need sunlight. So those are the main three things that they need in order to grow. They need some water, they need warmth, and they also need nutrients. just to give you guys an understanding, if we remember, those are the things that we need in order for respiration, for making energy to happen. You need sugar, you need a little bit of warmth so the enzymes work fast, and you also need you need water involved for enzymes to be able to move about. So the main thing that it needs is sugar. You don't actually need oxygen because they can do it anaerobically. So what will happen is if you leave yeast in those conditions, they start reproducing quite a bit. So I have a graph here, it's known as a population growth curve, where at the start we have only a few yeast cells, and then it grows and grows and grows until eventually it levels out. And the reason why it levels out is because there's usually a limit to how many resources there can be. So for example, if there was a limited supply of water, that would limit how many yeast cells can be in a particular area. If you start cooling it down, that might limit it. Or if you have a limited amount of sugar, that will limit it as well. In this case of this graph, the limiting factor was glucose, which is sugar. But in general, a limiting factor could be anything. It could be anything that basically tops off the population. Now, last thing, we used yeast for quite a few things. On Show My Homework, you'll see the mini projects that Mr. Durston set talks about these two things as well, baking and brewing. So because you guys might already have some background knowledge on this, like for example, Lucy mentioned that you use yeast to bake. And the reason why that they get used for these things is because of the chemical reactions that happen. So for example, with baking, if we expose yeast to oxygen, they start doing aerobic respiration. And remember the word equation for aerobic respiration is glucose, which is the sugar, plus oxygen. I'll write that a little bit better. Aero, carbon dioxide, plus water. So, let me ask you this. Let me draw a sticker again. Why does bread rise? We use yeast in bread, so whenever we make the dough, we put a little bit of yeast in there. What causes the bread then to rise and become fluffy? Sticker for whoever can tell me. No, it's not because they die. What causes the fluffiness? Think about the word equation. Okay, let me re-ask my question. So, when you're making bread, you put the flour, the ingredients together with a little bit of yeast, and what happens when people make bread is that they fold it repeatedly to get as much oxygen in there as possible. And then when they leave it there, the yeast performs aerobic respiration in the bread, in the dough, and then it makes the bread rise. What substance is causing that bread to rise? So the yeast is doing something. It's not, it's not dead yet. The yeast is doing something to cause the bread to fluff up a bit. Think about the word equation. This is what yeast is, very good. So if you think let's look back to the word equation now. Okay, you put yeast in the bread. You fold it in with you fold it repeatedly to get as much oxygen in the bread as possible. And then what ends up happening is the yeast, they respire aerobically, meaning they are going to be producing carbon dioxide. So if you think about what's happening inside the bread to make it fluff up, to make it rise, is that the yeast is producing that carbon dioxide gas, and that is making the bread fluffier and fluffier. So for those of for anybody who has tried making bread before, but the bread ended up a bit flat, it might be that they didn't use yeast, or it might be that you didn't leave the yeast long enough to rise, or it might even be that, for example, if you didn't fold in enough oxygen, we didn't actually get as much carbon dioxide produced, because for the word equation, the yeast needs glucose, it needs sugars, it needs oxygen folded into the bread, and then it produces carbon dioxide that makes the bread fluffy. Okay? Now, with brewing though, that is the opposite of baking, meaning it's got a different process going on. It uses anaerobic respiration. So that is without oxygen. And what it does is it takes the sugar that's available, and instead of combining it with oxygen, it breaks that sugar down directly into carbon dioxide plus ethanol. And ethanol is the alcohol then that people would drink. So, for a bit of practice, you have some options. What I have on the website are a few tasks for you guys just to get some extra practice. But with practice, you could go straight into Seneca and do practice there, or you can go straight into the mini projects. Remember, those two things are the bare minimum of what you have to do. But I do recommend getting a little bit of extra practice in so you feel a bit more confident in the topic. Max, lactic acid is something that yeast doesn't do, but it is a different type of anaerobic respiration, but very good. It is a different type. So for example, we form lactic acid with anaerobic respiration, and bacteria also do, but yeast don't. Yeast directly breaks it down into carbon dioxide and ethanol. So if you click on, I've jumped straight to lesson 2. I've done a bit of lesson 1, but I want to jump straight to lesson 2 just so then we get as much done as possible because of time. You have a task. So once again, this is completely optional additional work. The bare minimum that you have to do that we're going to be looking at is your Seneca, the quiz that is going to be put up on Show My Homework after Easter, which is basically our topic test. And also we're going to be looking at the mini projects that you do for Mr. Durston. But this is just for additional practice, and I'm going to be going over the answers to this. So what I've done is I've split this task into basic sections. We have basics of just, recall. Do you remember what has been taught? And then some thinking skills. And one thing that I would like you guys to do, and if you do this, make sure you send me a picture of what you've done, because that, I'll put it on Twitter. That'd be really awesome. If you make bread using yeast and do that technique where you fold in as much oxygen as possible, so then they could perform respiration as much as possible to make nice fluffy bread. And if you want to go on to challenge, this is basically just stretching questions where we're thinking about, here's an unfamiliar context. Can you apply your knowledge to that unfamiliar context? Yes, Lucy, but you still need to make the dough. Okay, so I have that task for you. I'll be putting up the answers as well on the website. But so for now, what I want you guys to do is do the Seneca for unicellular organisms. Do whatever Show My Homework mini projects that you can do now. I believe on the Show My Homework, the mini projects for this topic, you would be able to do task 1, which is what are unicellular organisms? And you can do half of task 2, where you can talk about how we make bread and how we make beer, because we mentioned how yeast, it gets used in brewing. So you can talk about, you can do task 1 right now and half of task 2, hopefully with confidence. If you want to do any additional practice to really stretch yourself, then feel free to work on this task. And at 11 o'clock, I'll be putting up the answers to this. And remember, if you make any bread, if you have a go at thinking skills section, and if you make any bread, please send me a picture through email. Does anyone have any questions or something that you'd like to go over again? No, Freya, because that doesn't use the yeast. Yes, so in terms of what you have to do, it's Seneca. And the mini projects that Mr. Durston put up on Show My Homework, you can do the first one and half of the second one now. For optional tasks that you just want to get a little bit of extra practice on, then I have those additional resources on the website. So you can do lesson 1 and lesson 2 now. And then I'll put those answers up in a bit. But remember, this is just optional, so don't feel overwhelmed like, oh, I have to do all of this. The only things that you have to do are Seneca, the mini projects, and then after Easter, there's going to be a topic test on Show My Homework. Okay? Any other questions? Okay, great. So I'm going to end the stream now. In about 30 minutes time, I'm going to be putting up the answers to any of the level task sheets, just so then you guys could, think about what you've done and have a check of your answers. I'll I'm available on email or show my homework if you guys want to have me re-explain why I got a certain answer, or you're not sure where you went wrong or something like that. Okay? Right, have a good day, everybody. Make sure that you are taking care of ourselves mentally and getting enough exercise. See you.